In the golden age of agricultural innovation, between the 1920s and 1970s, engineers created some of the most ingenious farm machines the world has ever seen. But as technology evolved and farming practices changed, many of these remarkable inventions were left to rust in forgotten barns and fields. Today, we're diving into 10 incredible farm machines that time forgot, machines that, with their robust design and simple mechanics, could still outperform modern equipment on today's job sites. Let's get started. Number 1. The Case by Eagle Hitch Tractor is the Case by Eagle Hitch Tractor series from the 19th. Now, you might be wondering what made this tractor so special. The answer lies in its revolutionary 3-point hitch system that predated the now universal Ferguson system used on virtually every modern tractor. The Eagle hitch design was actually superior in some ways to what eventually became the industry standard. It featured a unique hydraulic system that allowed for incredibly precise implement control, with the ability to maintain constant draft regardless of ground conditions. This meant farmers could achieve perfectly consistent plowing depth even on uneven terrain. What makes this machine relevant today? Its mechanical simplicity. Unlike modern tractors with their complex electronic systems and emission controls, the Eagle hitch tractors were built with straightforward mechanical and hydraulic systems that almost anyone could maintain and repair. On construction sites where reliability trumps GPS guidance and computer controls, these tractors would be absolute workhorses. Plus, with horsepower ratings between 25 and 60 HP, they're perfectly sized for small to medium operations that don't need a massive six-figure investment in modern equipment. Number 2. The Minipalus Mullen Uni Harvester. Introduced in this machine was decades ahead of its time, with a concept that's only now being rediscovered: the self-propelled, multi-purpose harvesting platform. The Uni Harvester was essentially the world's first true combine harvester that could be easily converted between different crops. With interchangeable headers, it could harvest wheat, corn, soybeans, and even flax, all with the same base machine. The genius was in its modular design, but here's what really sets it apart. The Uni Harvester featured a 26-foot wide cutting platform at a time when most combines maxed out at 12 feet. It wasn't until the 1970s that the industry caught up to this width. The machine used a straight-through design that minimized grain damage and loss, achieving efficiency rates that would be respectable even by today's standards for modern applications. Imagine this. A construction or landscaping company dealing with large-scale site clearing could adapt this platform concept. The heavy-duty chassis, powerful engine, and modular attachment system would make it ideal for mounting different implements, from mowers to brush cutters to debris collectors. The mechanical reliability of these 1930s powertrains often exceeds modern equipment that's plagued by electronic failures and emission system problems. Number 3. The Roomley Oil Pull Tractor. We have a true icon of agricultural engineering, the Roomley Oil Pull Tractor. Manufactured from 1910 to 1931, these machines earned legendary status for their ability to run on low-grade fuel oil or kerosene, fuels that cost a fraction of gasoline. The oil pull design featured a massive oil-cooled engine. Yes, oil-cooled, not water-cooled. This revolutionary cooling system used the tractor's own oil reservoir, which circulated through a radiator. This meant the oil pull could operate in freezing conditions without the risk of coolant freezing, and in dusty conditions without radiator clogging. These tractors were built like battleships. The larger models, like the 30 to 60 oil pull, produced 60 belt horsepower and could pull 30 horsepower at the drawbar. They weighed over 10 tons and featured steel wheels that could grip virtually any terrain. Original oil pulls that still run today, and many do, can operate for 12 to 16 hours a day without mechanical issues. For today's job sites, particularly in remote locations or developing regions, the oil pull's fuel flexibility would be invaluable. With modern diesel prices fluctuating wildly, a machine that can run efficiently on waste oil, biodiesel, or low-grade fuel oil would offer tremendous operational cost savings. The simple two-cylinder engines are so robust that maintenance can be performed with basic hand tools, and parts can often be fabricated on-site if needed. Number 4. The John Deere Dane Hay Press. To the John Deere Dane Hay Press, produced in the early 1900s. This power-driven hay baler revolutionized hay processing by creating dense, uniformly sized bales that were easy to transport and store. What made the Dane system special was its horizontal baling chamber and continuous feed mechanism. Unlike earlier stationary presses that required manual feeding and operation, the Dane press could be powered by a tractor's PTO or a separate engine, and featured an automatic feed system that maintained consistent bale density. The machine produced bales weighing between 100 and 150 pounds, the perfect size for manual handling without being too heavy for one person to lift. The baling chamber design created bales so tight that hay loss during storage and transport was minimal, often less than 5%. Today's applications think beyond hay. This compression technology would be perfect for recycling operations, compressing cardboard, plastics, or other materials. The mechanical advantage system used in these presses with their massive flywheels and lever arms generates incredible force using relatively little power input. Several organic farms and sustainable agriculture operations have actually restored these machines for exactly this purpose, finding they're more reliable and easier to maintain than modern balers that cost 10 times as much. Number 5. The Oliver Superior Grain Drill is the Oliver Superior Grain Drill from the 1930s and 40s. This precision planting machine represented the peak of mechanical seed metering technology before the age of electronics. The Superior drill featured individual seed cups for each row, driven by a ground-driven mechanism that ensured perfect seed spacing regardless of traveling speed. The ingenious force feed system could handle seeds of vastly different sizes and shapes without bridging or plugging, a problem that still plagues some modern equipment. What really set this drill apart was its adjustable depth control system. Each opener could be individually adjusted for planting depth, and the system maintained that depth even in varying soil conditions through a spring-loaded pressure system. The fertilizer attachment could simultaneously place fertilizer at precise depths and distances from the seed. For modern construction and landscaping crews doing erosion control or large-scale seeding operations, these drills would be incredibly valuable. They require no computers, no GPS, no electronic sensors, just clean, mechanical precision. The robust construction means they can handle rocky, rough terrain that would damage modern precision planters. And here's the kicker. Properly maintained Oliver drills from the 1940s regularly achieve seed placement accuracy within a quarter inch, which matches or exceeds many modern drills costing $50,000 or more. Number 6. The Caterpillar 30 tractor is the Caterpillar 30 tractor, produced from 1925 to 1932. While Caterpillar is known today for massive earth-moving equipment, the 30 was designed specifically for agricultural use and became one of the most versatile machines of its era. The Cat 30 featured a 4-cylinder engine producing approximately 30 belt horsepower and weighed around 5,700 pounds. But the real innovation was in its track system. The relatively narrow tracks, about 10 inches wide, distributed weight effectively while still allowing the tractor to navigate row crops without damaging plants. The track design also gave it extraordinary traction in wet or muddy conditions, where wheeled tractors would bog down hopelessly. The engine was a masterpiece of simplicity, cast iron construction, magneto ignition, and a design that could run on distillate fuel, which was much cheaper than gasoline. Fuel efficiency was remarkable for its time, averaging about 2 gallons per hour under heavy load. For today's applications, imagine a Cat 30 on a construction site in wet, muddy conditions. While modern equipment sinks or struggles, this 90-year-old design would walk right through. The low ground pressure, often less than 5 psi, means minimal soil compaction, making it ideal for sensitive sites. Restoration enthusiasts report that a properly restored Cat 30 can outwork many modern compact track loaders in soft ground conditions at a fraction of the operating cost. Number 7. The Massie Harris No. 3 Reaper Thresher. We have the Massie Harris No. 3 Reaper Thresher, introduced in the early 1900s. This machine was a marvel of mechanical engineering that combined cutting, threshing, and cleaning operations in one ground-driven platform, no engine required. The genius of this design was its power transmission. The bull wheel, a large drive wheel on the side of the machine, turned as the horses pulled it forward. This rotation powered the entire mechanism through a series of gears, chains, and sprockets. The cutting platform, threshing cylinder, separation screens, and cleaning fan all operated in perfect synchronization, powered entirely by the forward motion of the machine. The threshing cylinder featured a unique rasp bar design that was gentle on grain, reducing damage to less than 2%, better than many early powered combines. The cleaning system used variable speed fans that could be adjusted for different grain types and moisture conditions. Why would this matter today? For small-scale organic farms, sustainable agriculture operations, or developing world applications where fuel costs are prohibitive, a ground-driven system requires zero fuel and minimal maintenance. Several agricultural museums have demonstrated that a team of 4 horses pulling a restored number 3 can harvest 2 to 3 acres of small grain per day, producing cleaned grain ready for storage. For operations prioritizing sustainability over speed, this technology is actually being rediscovered. Number 8. The International Harvester Farm. All regular, produced from 1924. This tractor literally revolutionized agriculture by introducing the concept of the all-purpose tractor, a machine that could do field work, cultivate row crops, run belt-driven equipment, and perform general farm duties. The farmall's most innovative feature was its tricycle front wheel configuration and high ground clearance. With 30 inches of clearance under the rear axle, farmers could cultivate tall crops like corn without damage. The narrow front wheels could run between rows, while the rear wheels straddled the row or ran in furrows. The engine was a 4-cylinder design producing about 20 horsepower, using a thermosiphon cooling system that had no water pump to fail. The transmission offered 4 forward speeds, and the PTO power takeoff system could run implements independently of the tractor's ground speed. But here's what makes the farmall relevant today. Its power-to-weight ratio was nearly perfect for small to medium operations. At just 3,650 pounds, it delivered excellent traction without causing soil compaction. Modern compact tractors weighing 5,000 to 6,000 pounds cause significantly more soil damage while delivering similar or less usable power. For market gardens, orchards, vineyards, and specialty crop operations, the farmall's size and maneuverability are ideal. The mechanical simplicity means repair costs are minimal. There are no DF systems, no DPF filters, no electronic fuel injection to fail, just straightforward, reliable mechanical power. Number 9. The Oliver 70 Row Crop Tractor. We have the Oliver 70 Row Crop Tractor, produced from 1935 to 1948. This machine represented the absolute peak of pre-electronic tractor design and introduced features that wouldn't become industry standard for another 2 decades. The Oliver 70 featured a high-compression 6-cylinder engine at a time when most tractors still used 4-cylinder designs. This 201 cubic inch engine produced 28 belt horsepower, but delivered power so smoothly that operators reported significantly less operator fatigue during long workdays. The engine could run on gasoline, distillate, or even low-grade tractor fuel with minor carburetor adjustments. One groundbreaking feature was the independent PTO, the first widely available tractor to offer power takeoff operation independent of the transmission. This meant implements could continue operating while the tractor was stopped, a feature considered revolutionary at the time. The Oliver 70 also pioneered high-clearance designs, with some models offering up to 32 inches of crop clearance. The adjustable wheel tread allowed configuration for row spacings from 48 to 96 inches. For modern applications, the Oliver 70's 6-cylinder smoothness and fuel efficiency make it ideal for continuous operation tasks. Restored models regularly achieve fuel economy of 3 to 4 gallons per hour, doing heavy work, comparable to modern tractors of similar power. The mechanical governor system maintains engine speed within 50 RPM under varying loads, which is adequate for most PTO-driven equipment. Several custom harvesting operations still use Oliver 70s for running small grain equipment, finding them more cost-effective than purchasing modern tractors. Number 10. The Russell Giant Steam Traction Engine. We have the ultimate powerhouse, the Russell Giant Steam Traction Engine. Manufactured from 1910 to 1924, these behemoths represented the absolute peak of steam power technology in agriculture. The Russell Giant wasn't just big, it was colossal. Models ranged from 60 to 110 horsepower, with the largest engines weighing over 20 tons. The massive boilers operated at 150 to 180 psi and could maintain steam pressure for hours of continuous heavy work. These machines pulled plows with 20 to 30 bottoms, threshed grain at rates of 1,000 bushels per hour, and powered sawmills that could process entire forests. What made the Russell engines special was their engineering sophistication. They featured compound engines, high-pressure cylinders exhausting into low-pressure cylinders, which extracted maximum energy from steam. The result was fuel efficiency that seems impossible. These engines could operate for 10 to 12 hours on 500 pounds of coal. The traction system was equally impressive. Massive steel drive wheels with lugs or spikes, combined with the engine's enormous weight, generated drawbar pull measured in tons. Contemporary reports documented Russell giants pulling loads that required 6 modern diesel tractors to match. Now, you might think steam power is obsolete, but here's why you'd be wrong. These engines can burn virtually any combustible material: coal, wood, agricultural waste, even municipal waste. For operations in areas with abundant biomass or waste materials, a steam engine provides essentially free power after the initial investment. Several lumber operations in the Pacific Northwest have actually restored Russell giants for log hauling, finding that they can run all day on mill waste, wood chips, bark, and slash that would otherwise require disposal costs. The engines require no diesel fuel, no DF fluid, no emission controls, and produce nothing but water vapor and CO2 from burning biomass. For heavy construction work, pulling scrapers, operating cable systems, or powering large stationary equipment, the smooth, consistent power delivery of a steam engine is actually superior to diesel power for certain applications. The torque curve of a steam engine is essentially flat, full torque available from 0 RPM up to maximum speed. What do you think? Would you trust your work to 100-year-old technology? Let us know in the comments below. And if you enjoyed this journey through agricultural history, don't forget to like this video and subscribe for more content on the machines that built our world. Thanks for watching.